All right.
Awesome. Hi, everyone. We're so happy that you're here. We have a nice group. Okay. Douglas Koval, you can completely take over. I'm really excited that you're all here right now. And let's listen in without further ado. Okay, go ahead, Douglas. All yours. Okay.
All right. Also, hi, everyone. So today's webinar is going to be our second webinar in the series of 4 that we're doing. So today's webinar is going to focus on the math section of the SAT specifically. So as far as the format for today, it's going to be pretty similar to the format we had last week for those of you who are here at the reading one, although the timing of things might be a bit different. So I'm going to start out by just kind of giving you a general overview of the test, so what to expect in terms of the format, as well as the scoring, which could be a little bit weird when it comes to the math part specifically, and the concepts that are actually covered on the test. Then I'll give you some advice on how to prepare for the math section. And this part will be definitely not as detailed as last week's was, because the math section, as I'll mention when we get to that slide, is a lot more straightforward to prepare for than the reading part. Then I'll give you kind of a brief description of the 2 math books that we have. And then finally, we'll start working through questions from the March 2021 no calculator section of the SAT. So we're likely not going to be able to finish the entire section. So we'll just get to whatever we're able to finish by around 8 o'clock is what we'll do. And then whatever we're not able to do from that, we'll probably cover in the hard math webinar in 2 weeks. So for those of you who are thinking about going to that webinar is going to be a little different than the other 3. So I might do like a very brief introduction, but for the most part, it's going to be working through harder questions in 1 or 2 SATs. So we'll probably start with the March one, and then if time, probably the May one we'll look at from last year. All right, so as far as the test format, so there are 2 math sections on the SAT. So the first section is no calculator. So there are 20 questions and 15 of them are multiple choice. You have 4 choices each, and then 5 of them are grid-ins where you have to enter in a number, and you have 25 minutes for that part. And then the calculator section is 38 questions. So 30 of them are multiple choice, 8 are grid-ins, and you have 55 minutes for that part. And I do recommend using a graphing calculator if you're able to access one, because it could definitely be helpful on a few of the questions. And there's kind of a few technical things to note about the format that I think are useful to know. As far as the grid-in section, you're only allowed to enter in whole numbers that are greater than or equal to 0. So no negative numbers are allowed. Or you could enter in decimals or fractions, but they have to be improper fractions. So if you enter in a mixed number, it would be incorrect. So for example, if the answer are 1.5, you'd have to either grid in 1.5 or 3/2. If you were to actually grid in 1.5, the Scantron would read that as 11/2. So sometimes students kind of mess up by doing that. Another important thing where sometimes students kind of mess up with the grid is they round when they're not supposed to. So always read the directions carefully. So for example, if the answer is 1/3, either write 1/3 or 0.33, but don't write like 0.3 or you would be marked off. So those are things to be aware of as far as the grid-ins. And then another general thing that's useful to be aware of with the format is, unlike the English section where the questions tend to go kind of roughly, unlike the English section where the questions are kind of in random order as far as difficulty, that's not really the case with the math part. So for example, the easier questions tend to fall at the beginning of each multiple choice section, and then the harder ones at the end, and the more medium ones in the middle. And then the same thing with the grid-ins, although it's a little more random with that, but in general, the easier grid-ins tend to fall towards the beginning and the harder ones towards the end. And then the last thing from this slide that I wanted to talk about is the scoring, where things could sometimes get a little bit strange on the math section in particular. So the raw score is the total number of questions that you get correct out of 58. And so you get 1 point for every question you get right, and then 0 for every one that you either leave blank or get wrong. So you might as well guess on everything, even if you have no idea, because it could only help your score. This wasn't always the case with the SAT. There actually used to be a wrong answer penalty to discourage random guessing, where people who put a wrong answer on a multiple choice actually got -1/4 towards their raw score, but that no longer exists. But the raw score isn't what matters. So it's actually the scaled score, which is your score from 200 to 800. And then a common question that sometimes I get from students and parents is, how many questions can they get right in order to get a certain score? So like, how many questions am I allowed to get wrong if I want to get a 700 or a 650 or 600 or 750, whatever your goal is? So the answer is, it really could depend, and it could be quite drastic from one month to another. So as I talked about a little bit last week on the reading part, the SAT uses a process known as equating, and that's done to ensure that scaled scores have the same meaning, regardless of whether a student happens to randomly get a harder test or an easier test. So a 700 has the same meaning as a 700 on a different edition of the test, even if one test happened to be harder than the other. So they give you kind of extreme examples from some past years. So there was one month where 56 out of 58 right was actually a perfect 800. And that's actually really rare. Usually you need to get everything right to get an 800. Sometimes you could get one wrong, but very rarely you can get two wrong. And I think on that test, I just looked it up yesterday, 11 questions wrong was actually a 700. And again, typically you could only get around 7 to 9 wrong to earn that. So that was a very generous curve. And a lot of students who kind of walked out of that test feeling like they did horribly, were kind of freaking out, were kind of pleasantly surprised when they got their grades back and they saw that they actually did much better than they thought. In some cases, they actually improved from how they normally did, despite getting more questions wrong. On another extreme case, which was, I believe, the June 2019 test, 2 questions wrong was actually a 750 and 4 questions wrong was a 700, which is really kind of extreme in the other direction. And on that test, a lot of students walked out of the test feeling like they did really well, only to be disappointed to see that their grades either stayed the same or went down from a previous time they took the test, despite the fact that they got more questions right. But the reason they got more questions right wasn't that they got so much better at math, but it was because the tests actually just got so much easier. So the College Board, a lot of students actually petitioned to the College Board that month to try to get them to change the scoring. It was a whole thing in the news. Some of you might remember seeing it. But of course, they didn't listen because that wouldn't have been fair to people who took a harder version of it. But I think the problem with that particular month is they just made a test that was too easy, that it wasn't able to precisely differentiate among those top scoring students, which is why you saw such a steep score drop for getting so few questions wrong. So just be aware in advance that that's something that could potentially happen. Probably it won't be as extreme as that case because of the bad press they got, but do know that from month to month, there is variation in difficulty. So don't necessarily be surprised if on a month where you get more questions right, your score doesn't actually change very much, especially if it's only like 1 or 2 more questions right than you did before. So they're just kind of important general things that you should be aware of. And then the last thing I want to say about the format has to do more with the test content. And this is really important to know, especially if you're kind of debating between taking the SAT versus the ACT, where it's a little bit different in terms of the math that they emphasize, although there is some overlap. So the ACT, which I'm not going to really go into today, is really kind of a sampling of all the math you do throughout high school and even middle school. But the SAT, I would say, is a very algebra heavy test now. So overall, the questions fall into kind of 4 broad categories. So the first category are the heart of algebra questions, which you see are about 33% of the test. So these questions primarily test your ability to analyze, solve, and create linear equations, as well as systems of linear equations. And to a lesser extent, they also test linear inequalities and systems of linear inequalities. And the next broad, and most of this material you should have learned back in Algebra 1. So it seems to be pretty closely aligned with the Common Core of Algebra 1. But just one thing to be aware of, it's possible that your teacher or the regents might have emphasized some material in a slightly different way than the SAT does. So some of the stuff might seem a little bit new, but in general, you should have learned all of that content in your Algebra 1 course. And then the next broad category are the problem solving and data analysis questions. So this is about 29% of the questions on your test. So unlike the other 3 categories of the test, which could be on both the no calculator and calculator part, these questions are only on the calculator section. And in general, what they have in common is they involve you trying to apply your knowledge of math to more real world contexts. But I would say broadly, these question types fall into kind of 2 broad categories. So the first category of topics are really very measurement related topics. So questions like this might involve you working with proportions or ratios, unit rates, percentages. And a lot of that stuff you actually probably did more in your pre-algebra classes, like in middle school, than you did in high school. So some of this stuff might be things you need to review on. So percent change, for example, is a topic that's pretty big on the SAT that a lot of students often forget because they haven't really done it in that long of a time. And then the other broad category of topics within this unit would be the more statistics and probability related section. That's why it's called data analysis. So this stuff is probably scattered throughout your middle school and Algebra 1 and Algebra 2 courses. But if you are someone who's in AP Stat or you have taken it, then the statistics you do in that class is way more advanced than anything that the SAT tests you on. So you should be well prepared for at least the statistics and probability related questions. And the last major category is a passport to advanced math. So these questions primarily deal with your understanding of nonlinear equations, such as quadratics and polynomials. They also deal with kind of rearranging expressions to isolate a quantity of interest. So they might give you a complicated equation, and you have to rearrange it to get a certain variable by itself, for example. And they also deal with function notation. So some of this material was definitely covered in Algebra 1, especially some of the more basic stuff like combining like terms and some basic factoring. But then a lot of it was also covered in Algebra 2. So if you're in that class now, it's possible that some of that material you might not have learned yet, but by the end of the year, then you should have learned everything you need to know for that. And then finally, there are additional topics in math. And this is kind of where the SAT is a lot different from the ACT. So you have 6 questions that are going to be on geometry, trigonometry, or complex numbers, whereas on the ACT, this is a much larger part of the test, probably closer to a quarter. So if you're someone who really doesn't like geometry and you prefer algebra, then at least for the math part, the SAT might be a better fit for you. So next, I'm just going to go into some advice on how to study for the math part. So the most important thing, especially if you're looking to get above a 700, is you really want to make sure you learn all the concepts, rules, procedures, formulas you're responsible for on the exam. And there are a lot of them, but there's a good chance that you already know a lot of them. And it's more going to just be kind of filling in those gaps with the few things you don't know. The second piece of advice, if you feel like you're one of those people who's overly dependent on your calculator, you might want to review some basic operations without a calculator if needed for the no calculator section. So I often have students who they set up equations perfectly and then they're not able to solve them without the calculator because they forgot, how to divide fractions or something like that. So if you're a little rusty with that stuff, that's definitely something you want to review. Though I will say for the most part, the computations on the no calculator part generally tend to be pretty basic. They shouldn't usually be too time consuming, but occasionally they can be a little bit. And then the next big piece of advice is you definitely want to make sure you're doing practice tests regularly. So I would say ideally once a week or at least every other week. But even more than just doing a lot of practice tests, it's really important that you study your errors deeply. So you really want to be reflecting on why you got the questions wrong that you did. And one way that you can do this is by keeping an error log, which is something I actually learned about fairly recently for each test you do. And there's some templates for this online, or you can make your own in like a Word file or Excel file. But basically what you would do is for each question you get wrong on a practice test you do, you should note the question number, and then you should have some sort of, I recommend an explanation for how you would get to the right answer. But then also you should reflect on why you got the question wrong the first time, and then kind of a deeper lesson learned, because you're probably never going to see that exact question again, but you might see a similar question like that in the future, and you want to know why you're getting them wrong in the first place, and that could kind of affect the way you study. So this is an example in my Harvard program, which we talked about a little bit last week, where we study kind of the brain and how people learn. This is called metacognition, when you kind of think about your thinking. And that's something that actually helps you perform better. So they give you kind of an example. So 2 students might get the same question wrong, but for very different reasons. So on the no calculator section, which we're going to look at today, there's one question, which is number 18, which I don't think we're going to have time to get to today. So we're probably not going to until the hard math webinar. But there's one question that does require you to either use the quadratic formula, which most students do, or complete the square to get the right answer. So some students get that question wrong because they know they need to do the quadratic formula, they just haven't memorized it yet. So the lesson learned for them would be, I need to memorize this formula so I could do it when I see a question requiring it on the test. But on the other hand, there's some students who actually did memorize the formula and they know it fine, but they didn't even realize they had to use it. So in their case, the problem wasn't that they didn't have the knowledge, it was that they didn't realize that they needed to apply it. So for them, the lesson learned might be, if I see a quadratic equation and they want a solution in radical form, that means I have to use the quadratic formula and not try and factor. So depending on why you get questions wrong will kind of affect how you study. And as far as how I prepared for the math part, so basically, like I said last week, the math part was the one that didn't come as easily to me as the English section. So the first time I took the SAT, I went into it more or less cold just to kind of see how I do. And I was really happy with my English score, but I was not happy at all with my math score. So what I did is over the summer, I went through the copy of my tests, because as you might know, the College Board does release the exams for 3 months of the year. So I happened to take it one of the months that they did release it. So I went through all the questions I got wrong, and I really deeply analyzed why I got each of them wrong. I figured out how to get the right answer. And then after each question, I really reflected on them, because I knew I wasn't going to see those exact questions again, but I knew there was a good chance when I retook it that I might see a question like it or one that required a similar approach. So I really wanted to make sure I understood each question really deeply and try to think of the broader patterns within each one so I would know how to approach them in the future. And it ended up really helping me when I went back and retook it in the fall by having done that over the summer. The next thing that you want to do is you want to make sure you drill material based on the question types you get wrong. So for example, if you're always somebody who gets questions wrong on, let's say, systems of linear equations, then you know that's a topic you're going to need to practice more. And you want to practice it until it's more or less second nature for you. So in my book, which I'll talk about on the next slide, there are plenty of drilling in there, but Khan Academy also has drills. You could also find ones online. Sometimes with my private students, I'll give them worksheets on the question types that got wrong. So they practice them until they're more comfortable with it. So drilling is really important to kind of hone in on those few areas that you're a little weak on. And then finally, this last thing isn't really advice, but just more of a general comment, how on the math section of the SAT as it exists now, for the most part, there are very few trick questions. So a student who really knows all the math knowledge tested, they should be able to get at least a 650 to 700 minimum, assuming they don't make any careless errors. I just made it 650 in case it's one of those weird tests like the June 2019 one with a really odd curve. But on a normal month, a student who gets lower than 700, even if it's like a 680 or 690, like a really good score, it's usually because they had some sort of gap in their knowledge. It wasn't just that they didn't understand the questions. That doesn't mean there aren't going to be a few questions that require, more creative or flexible thinking, or that require you to really read carefully to kind of figure out what's going on. But for the most part, I would say the questions are very straightforward if you know what the rules are, what you're supposed to do. So finally, before we actually get into going through the March tests, I just wanted to make a few comments about the book. So some of you might not, or some of you might have it, some of you might not. So I have two math books. So the primary Kweller Prep math book has 39 lessons divided between 4 units, and it's 590 pages. So it's very long. It's definitely the longest book of all of them that I've made. And each lesson contains detailed notes along with model problems, drills, and work solutions. And then one thing I want to note is that the lessons do build on each other, but high scoring students might prefer to skip around to their problem areas based on the question types they get wrong on real tests. But I do recommend, if you have the time to actually kind of go through it straight through, at least for the first 3 units, which are the heart of algebra, problem solving, and passport to advanced math. The additional topics of math, again, is only 10% of the test. So that's probably the least priority to go over. And then one thing I want to bring up is kind of a piece of advice, which I actually learned back when I was teaching test prep courses for a different company a long time ago. They told us that we should try to focus on concepts, not problems. So in other words, don't get too caught up in all the specific questions that you go through, but think about kind of the deeper concepts that the questions are testing. Because as much as I put in, every effort to anticipate every top possible type of question they could ask, I'm not psychic, and sometimes the tests, they do surprise me with the way that they present certain questions. That being said, the book does cover all the material that you need to answer pretty much every question, if not every question on any given test. But it is possible you might see a question on test day that looks a little different from the ones that you saw in the main book. So to give you kind of a real life example, I was just like a week or two ago, I was looking through the October 2021 PSAT, and I was really surprised by the last multiple choice question, which is generally the hardest one, that they had what I call abstract proportion questions. And I was kind of shocked to see it because I've never seen a question like that show up in the past 6 years since the SAT was redesigned. I did see questions like that on the old SAT back when I took it, when it was kind of more like of a logic test, almost disguised as a math test, but not since it became more straightforward. That being said, the book does go over proportions in, great detail. So a student who really mastered that concept should still be able to figure out how to answer that question. Interestingly, in my SAT math book, I actually do have a problem exactly like that, but on the SAT one, I didn't, but I do cover that concept. So if you focus on like learning the concept of proportions, then you'll kind of be more prepared if you do see a question that looks maybe a little bit different from the ones you practice with. That being said, though, I also have a hard math workbook that has additional practice material to supplement the main math book. So basically, that's just a workbook with practice questions kind of organized by topic. And it contains questions that are modeled after real questions that have appeared in past SATs. So right now it's been updated to reflect question types that have appeared through May 2019. But in the spring, I do plan on doing an update that will reflect questions that appeared up through last year, including a question like that proportion one that I mentioned to you. And I only recommend this book if you're already scoring in the 600s. If you're not in the 600s yet, then focus on the main book and learning all the foundational material. And then once you're consistently getting the 600s, then you could start practicing with the harder questions. So I think that's pretty much all I wanted to say in general for that stuff. So now we could actually spend the last half hour or so going through the March 2021 no calculator section. So again, we're not going to finish all of this today. So we're probably going to get through 10 to 15 questions or so. And then whatever we don't get through in this will most likely be harder questions anyway. So that's perfect for the hard math webinar. So today's mainly going to be on the easier and medium, and then maybe a few of the harder questions. So we're just going to kind of go through each question one by one. And for some of them, I already have some notes kind of typed out for you. So the first question is probably on the most important topic on the test, which is linear equations. So you're going to see, especially in the calculator part of this test, a bunch of questions that are some variation of this question. So here they tell you the function h is defined by h of x equals negative a fourth x minus 2. And they want to know which of these is the graph of y equals h of x. So just to go over some general notes for those of you who might have not done Algebra 1 stuff in a while. So the slope-intercept form of linear equations is y equals mx plus b. So m represents the slope, which you could think of as a rate of change, or it's a change in y divided by the change in x between two random points. And I kind of represented that formula there for you in blue. So y2 and y1 would represent the two y values of the two coordinates you picked, and x2 and x1 would be their x coordinates. And then b is the y-intercept, which is the value of y when x is 0. We're going to see a bunch of questions on the test dealing with this concept in some form or another. So in this problem, I could see that my m is negative a fourth because that's the coefficient to the x term. So I have a slope of negative 1/4, and then I have a y-intercept of negative 2. So the easiest thing to look for right away is the y-intercept because I could just see that visually. So automatically I could rule out A and B because I see those have y-intercepts of positive 2. Another issue with them is that they have positive slopes because they go up to the right, whereas I need a negative slope. So A and B are out because they have the wrong y-intercept. C and D, though, unfortunately, they do both have the correct y-intercept. So I have to do a little more work to figure out which has the correct slope. So I'm going to show you a couple of ways to do this. So like I mentioned to you, for those of you who didn't come to last week's webinar, so my master's that I took at Harvard was called Mind, Brain, and Education. So basically it was a lot about how people learn in the brain and brain-based research, things like that. So actually in the very first class I took, the class was called How People Learn. There is one of the math researchers was teaching us how students actually learn best when you show them multiple ways to do a problem. So I'm going to show you probably 2 or 3 different ways you could go about finding the slope. So the first way would be simply to kind of use this formula, y2 minus y1 over x2 minus x1. So if I were to pick a random point in number 1, like -2, +6, and then if I use like 0, -2, so this is for choice C. And then let's say I were to find the slope, I'm just going to label point. So I'll make that x1, y1, x2, y2. So it'd be -2 minus 6 over 0 minus -2, which ends up being -8 over 2, which is -4. So that's incorrect. But if I look at D, I see I have -8, 0 as a point. And I also have 0, -2. So if I do the slope between that, I should see that it ends up working out. So I could do -2 minus 0 over 0 minus -8. And I get -2 over 8, which is -1/4. So that works. So D would be correct. An easier way, since it's multiple choice, is you actually could plug in a point. So if I were to plug in -8, 0 back into my original function, so if I plug in -8 for x, you could see that I end up getting 2 minus 2, which is 0. But if I were to plug in -2 for x, I would not get +6. So that's another way to check it. And just kind of intuitively, I would probably be thinking D is right and not C. So just as a general kind of concept, the closer a slope is to 0, the shallower it will be, meaning it will look kind of more horizontal. So this slope, -1/4, is going to be a very shallow slope, and D seems to be a very shallow line, whereas C seems to be a very steep line. So I could probably already have a feeling that D is going to be correct. So that one, sorry, spent a little bit of time on that one, but I want to make sure you know how to be able to find the equation of a line, because that's going to be a very important concept that shows up on a lot of other questions in various different forms. All right, so questions 2 to 4 are definitely way easier. So these ones we'll get through really quickly. And then by question 5, we'll get into our medium difficulty questions. So for number 2, they want us to find the positive solution to the given equation. Just as a reminder, solution means the value of x. So probably the easiest way to do it would be you could subtract 10 from each side. So you would get x squared equals 81. And then you would take the square root of both sides. So you would get x equals plus or minus 9. So 9 would be the solution. You also could have subtracted the 91 to get x squared minus 81 equals 0. And then you could have factored using difference of perfect squares if you want to be a little bit fancier. And then you could set each factor equal to 0. And we see for the second factor here, you would get x equals 9. All right, so we'll go to number 3. So number 3, they just want to know what value of x satisfies the given equation. So once again, we're just solving for x. So just the key thing with here is to make sure you distribute that 3 to both terms in the parentheses. So we'd have x plus 7 equals 3 times x, because 3 times x is 3x. And then we'd also do 3 times -3. And then it's just pretty basic math from here. So add 9 to both sides to get 16, subtract x to get 2x, divide both sides by 2. And you get 8 equals x. So this one would be B. And then number 4 is the last of our easy questions. We actually just kind of talked about how to do this back on number 1. So they told us that we have a line in the xy plane with a slope of 1. So we know that m is 1, and it passes through 0, 2. So that's the y-intercept. Remember the point, the value of y when x is 0. So B is 2. So the only choice that matches with that is C. So A has a slope of 1/2 and a y-intercept of 0. B has a slope of 2 and a y-intercept of 0. So those go through the origin. And D has the right slope, but it has the wrong y-intercept. So that has a y-intercept of -2. All right, so now we're finally into our medium level questions. So before we look at 5, I just wanted to make a few notes about this concept in general, because 5 actually, I would say it's a borderline hard question. It could be very tricky if you overthink it. So sometimes you might have to set a linear equation in 2 different variables. So when you do that, you want to find the slope for each of the variables. So for example, suppose you have red tokens that are worth 3 points each, blue tokens that are worth 2 points each, where R is a number of red coins and B is a number of blue coins that you have, and you have Y points worth the coins. So if you were to write an equation modeling the situation, it would be Y equals 3R plus 2B. Because the slope of the red coins would be 3, because each red coin you have adds 3 points to your total. And the slope of the blue coins would be 2, because each blue coin you have adds 2 points to your total. And you could confirm this real number. So if let's say you had 10 red coins, that would be 30 points. And if you had 5 blue coins, that would be 10 points, which would add to 40. If I plug that back into my original equation, I would get that. So now let's look at number 5, which is similar. It just has one twist that it's kind of has to do with the language of it, which makes it a little bit weird. But for the most part, it's the same exact type of question. So if you just kind of remember what we did here, you'll be able to get 5 right. So from 1990 to 2001, German currency included coins called Pfennigs, worth 1 Pfennig each, and Groschen, worth 10 Pfennigs each, which equation represents the total number of Pfennig coins, P, and Groschen coins, G, that have a combined value of 85 Pfennigs. So the one point here where people can get a little bit thrown off is that one of the coin names, which is the Pfennig, is actually the same as the units they're measuring the currency in, and that could kind of be a little bit weird. So if you want, you could think of it as, this would basically have the same meaning. You could think of it as a Pfennig coin is worth 1 cent, a Groschen coin is worth 10 cents. How many of those coins are worth 10 cents? That's another way of kind of thinking of it. But if we approach it the way that we talked about before, find the slope for each coin, then it's a much easier question and it's harder to get yourself confused. So I know that the slope for Pfennig coins must be 1, because each coin just adds 1 Pfennig to the total value. And then the M for the Groschen coins must be G. because for each of those coins, I added a value of 10 pfennigs. So B shows me that situation. And you could confirm that by plugging in kind of real values that would make that make sense. Sometimes that's sometimes a way that you can make sense of formula questions where you want to pick a formula that represents a situation is to plug in like real numbers that would make that true. So for example, if you had 8 groschen and each groschens were 10 pfennigs, that would be 80 pfennigs. And then that would mean you'd have 5 pfennigs coins left over to be 85. And then if I look at choice B, if I plug in 5 for P and then 8 for G, I would get 85 and that works. But let's say if I were to plug it in the choice C, for example, which some students put, then you'd have 10 times 5 is 50 plus 8 is 58, and that would not be right. So sometimes you could kind of plug in your own real numbers. Honestly, the way I first did this to help me make sense of it, just to pick it in terms more relatable to me, I changed the word pfennig to pennies and groschen to dimes. And then I made it like how many pennies and dimes are worth 85 cents. And then it was a lot easier for me to kind of visualize. All right, so the next question, number 6, involves adding fractions. So I just want to go over that in general because a lot of students who I've worked with often forgot how to do this because it's been a while since they've had to do it without a calculator. So remember, whenever you're adding fractions, you always want to rewrite all terms with a common denominator. Remember, the denominator is the number at the bottom of a fraction, the numerator is the number at the top. And then once the denominators are same, then you could just add the numerators normally and keep the denominator equal. So for example, if you were given 1/3 plus 5, 6, I can't just make it 1 plus 5 is 6, 6 plus 3 is 9, and get 6 over 9. That would be wrong. So I need the denominators to be equal. So the common denominator is typically a number that both denominators divide evenly into. I usually like to use the smallest number they both go into. So in this case, I see, you could also think of it as kind of a least common multiple. So in this case, 6 would be the least common multiple of 3 and 6 because 6 goes into itself one time, and then 3 goes into 6 2 times. So 6 is the smallest number that 3 and 6 both divide evenly into. So I'm going to want to try to make both denominators 6. So the second fraction is actually already done for me. I don't need to do anything to that. And then the first fraction, though, I do need to make that 6. So in order for me to make 3 become 6, I need to multiply that by 2. And then whatever I do to the denominator, I also have to do to the numerator. So I end up with 2 over 6 plus 5 over 6 is equal to 7 over 6. If you didn't realize that 3 and 6 were the common denominator, you could have maybe made it 12. So you could have multiplied, let's say, 1/3 each of those terms by 4 to get 4 over 12, each of these by 2 to get 10 over 12. Then you would add them to get 14 over 12, which still reduces 7 over 6. So regardless, as long as you do a common multiple, you'll get to the right answer. So now let's apply that to this question here. So here I see I have 2 different denominators, so I can't just combine the numerators. So you see like choice D, for example, will be wrong because it just adds the numerators and adds denominators. So I need to make the denominators equal. So I see this that x and 2x both go into 2x because 2x goes into itself one time and x goes into 2x twice. So I'm going to rewrite the fractions so they have the same denominator. So my second fraction is all good. I don't need to do anything to it. And then for my other fraction, I'm going to multiply the numerator and denominator each by 2. So then I end up with the equivalent 2 over 2x plus 1 over 2x. And then I just simply combine the numerators. So I do 2 plus 1 is 3. And then the denominator stays the same. So then I'm left with 3 over 2x. So that would make my answer choice C. All right, number 7 is a little bit more of an obscure geometry topic. So I definitely want to go over how to do these in general before we take a look at this one. So I'm warning you in advance, I'm kind of doing a shortcut version of how to do this question because for the way this particular question is worded, you can do a shortcut that you can memorize. But if they had asked a slightly different version of this question, like if they wanted you to find radius or diameter, you'd have to do something called completing the square, which is a little more complicated. So I'm not going to get into that today, but it is something that's covered extensively in the book though. But as far as for this question, this is really all you need to know. So sometimes you're going to be given a circle equation in expanded form. So that would be defined as x squared plus ax plus y squared plus by equals c. And a and b represent whatever your coefficient for x and y are. So if you're just asked to find the center of the circle, all you need to do is divide a by -2 and b by -2, and that would give you the coordinates. So for example, looking at this model problem I made up here, and x squared plus 8x plus y squared minus 12y equals 10. To find the x coordinate of the center, I would just divide 8 by -2, which would give me -4. And then I would divide -12 by -2, which would give me +6, to give me an overall center of -4, 6. But one important note that I want to note, because this did show up in a different test one year, this shortcut only works if you have a 1 in front of the x and y squared, like we do here. So suppose they had put a 2 in front of x squared and y squared, like in the case of the problem I made up right here. So they could have written this as the equivalent 2x squared plus 16x plus 2y squared minus 24 equals 20. So then you would actually have one more bonus step. You'd have to divide everything by 2 to make it 1x squared and 1y squared. And then we end up with that same equation we had, and then we just do the math the same way. So keeping all of that in mind, let's take a look at number 7. So again, we see we have an equation in expanded form, and we just need to find the center. So again, we're going to do a, which is -10, divide that by -2, and then 6, and divide that by -2, which leaves us with 5, -3. So C would be the right answer. And again, if you needed to find the radius or diameter, though, then you would have to do completing the square, which, like I said, is a more advanced concept. And just for time's sake, I'm not going to get into that right now. All right, so number 8. I just have a few minor notes on how to do that, and then we'll look at 8. So if you're ever given a system of inequalities and you're asked to find a coordinate that's a solution, then you just need to plug each coordinate into both inequalities and look for the one that's true in both. So if it's true in only one, then it's not the solution. So to take an example, here we have these two inequalities, and they're saying when graphed in the xy plane, what point is a solution to the given system of inequalities? So I'm literally just going to kind of go through each choice one by one and plug them into both inequalities. So if I start with choice A, I see my x value is 1, and my y value is also 1. So I'm going to substitute in 1 for x and 1 for y into each inequality. So starting with my top one, I do 1 is greater than 4 times 1. And I get 1 is greater than 4, and I see that is not a true statement, so A is wrong. So now I'll move on to B. So I'll plug in -2 for y and 2 for x into the top one. And I end up getting -2 is greater than -8. That is a true statement, but I can't be sure that's the right answer because it's possible it won't work in the bottom one. So plugging in -2 for x and y into my bottom inequality, I get -2 is less than -2. -2 is less than +2, and that is true. So B would be correct. And again, it's really important that you plug into both, because to take an example, if you look at choice D, if I were to plug in 4 for y and -4 for x, I actually would get a true statement for the top one, right? Because a positive number 4 is bigger than a negative number, -16. But if I look at the bottom inequality, if I plug in -4 for x and 4 for y, I end up with the statement 4 is less than 4, but 4 we know is equal to 4. So that would be false. So that's why it's always important that you plug into both. And A, we were able, once we saw one didn't work, we were able to just move on. So you need to make sure that it works for both, not one. That's a very important thing to know. All right, number 9. Another topic which I have a few notes for that I want to read through before we look at the question. So in some word problems representing linear relationships, the slope, as you know from the graph question we did, represents the rate of change in terms of y per x. So for example, it might be miles per hour, people per year, degrees per meter. It's always something per something. But the key is that it's a rate of change, not the total change. And then the y-intercept you could think of as a starting value for y whenever x is 0. And again, remember, y and x represent kind of two real quantities. So in the miles per hour example, y would be miles and x would be hours. So to give you kind of a model equation, so suppose you were given the formula, y is equal to 45 plus 80x, where y is the money earned by an electrician and x is the number of hours worked. So in this case, I see that the slope is 80. And remember, slope is rate of change, or y per x. So that would mean that's what the electrician earns in dollars per hour. But then what does that y-intercept mean? So remember, the y-intercept is the value of y when x is 0. So if I plug in 0 hours, I still get a charge of 45. So how you'd interpret it in real life would be that it might be the flat fee. And I'm sure you might know that just from your real life, that oftentimes services, they might charge an hourly fee plus kind of a flat fee for signing up. So in this case, a flat fee might represent a fee for like maybe materials or something of that nature, or just for their travel time. So keeping all that in mind, we could now take a look at number 9. So the equation H equals 150 plus 10T gives the total number of housing units H in a community T months after a new zoning law was passed. How many housing units are added to the community each month after the zoning law was passed? So the keyword there is added each month. So this is a rate of change, which tells me that I'm looking for the slope. The slope is a total housing per month. So remember, it's y per x. In this case, y is housing and x would be my time. So the slope in this case would be 10, and that would be the answer. So now a common wrong answer that I've had some students put for this one who've done this test with me is they put 160. You could probably imagine where they get it from is they plug in 1 for t, and they see, oh, in 1 month we have 160 housing units, so that must be the answer. However, remember the y-intercept is your starting value. So even 0 months into when it was passed, we already had 150 houses to begin with. So 10 were actually added. And sometimes it could help for slope questions to kind of make a table of values. So if I'm just going to say t is 0, 1, 2, 3. So at 0 months, I have 150 units. So that's how many units I had before that law was passed. 1 month later is 160, but then 2 months later is 170. 3 months later is 180. So yes, I did have 160 units 1 month later, but I started at 150. So the slope is actually 10. So that's just something to be aware of. And then 150 we know represents the starting amount. All right, so now we're on to number 10, which I would say is the last of our medium difficulty questions on the multiple choice section. And then we'll be getting into our harder ones. All right, so number 10 is a subtracting like terms question. And believe it or not, a surprising number of students get these questions wrong, who are even like solid math students getting in the 600 or so. So the key thing you want to remember when you're subtracting like terms is to negate all terms after the minus sign. In the parentheses, a lot of students, what they'll do is they'll negate the very first term, but then they forget to for the others. So in this particular case, the term before the minus sign, so all of those first 3 terms, those don't change. So it's 2x squared plus 3x minus 2. And then here's where students tend to mess up. So then the negative 5x squared becomes negative 5x squared. So that part they do right. But then negative x actually becomes positive x because you have to distribute that negative. So negative 1 times negative x is positive x. And then negative 1 times negative 7 is positive 7. So now I could combine like terms. So 2x squared and negative 5x squared becomes negative 3x squared. Then I add 3x to x, and that becomes 4x. And then finally, the negative 2 and 7 becomes 5. So this would make D the right answer to number 10. So a common wrong answer that students would put is C, because you would get C if you correctly negated the 5, but if you left x as negative x and you left 7 as negative 7. All right, so now we're officially on the hard questions. So we'll definitely have time to do at least a few of these. Because I see we're a little low on time, I might save 12 for last as kind of a bonus one, just because it's an additional topic in math, and then come back to it at the end if we have time, or save that potentially for the hard math webinar, because the other problems are definitely much quicker. All right, so start with number 11. So number 11, actually, I'll admit, so I've been doing this kind of a long time, tutoring for the test. So anytime I look at a new SAT, especially the math part, I generally know like right away how to go about solving it. Number 11 was actually one that actually made me think for a little bit. And that doesn't happen very often, but in this one it did. And it was a little bit of a weird question that I haven't seen them word this way before. So this is kind of a good one to be aware of for how to do. So here they give you this equation of a polynomial function. So y equals x minus 1 times x plus 1 times x plus 2. And they tell you that in the graph of this equation above, so I'm just going to draw a coordinate plane, it has the point A, B. So A represents the x coordinate of some random point, and B is the y coordinate. And they tell you if negative 1 is less than or equal to A, it's less than or equal to 1. They want to know which of the following is not a possible value of B. So in other words, the x coordinate of some random point is between negative 1 and 1, and I want to know which of these is not a possible value of y. So to go about doing this, I would want to graph this. So if this had been a calculator question, I honestly would have just plugged this into my calculator and looked at the picture. but we don't have that luxury here. So we're going to actually have to kind of do a rough sketch by hand. So here I have some kind of general tips on how to sketch polynomial functions. So this is good for those when you have distinct roots, which means that no root is repeated, such as by being squared or cubed, which we don't have here. So the first thing you want to do is graph the x-intercepts by setting each factor equal to 0. So the x-intercept, so the factors would be each of these three parentheses. So I'm going to find each of my x-intercepts. So I would do x minus 1 is equal to 0, x plus 1 is equal to 0, and then I would do x plus 2 is equal to 0. So I would end up with x is equal to 1, x is equal to negative 1, and then x is equal to negative 2. So I would have 1 point here, 1 point here, and 1 point here. However, we still don't know exactly what the graph looks like, because maybe one possibility it could do this, but maybe, it goes the other way. We don't know yet, right? So how can we figure that out? So my next general advice is after you find the x-intercepts, graph the y-intercept by plugging in 0 for x and then finding y. So I'm just going to substitute in 0 in place of x. So I'd end up having y is equal to 0 minus 1.
Douglas, can you make the screen a little bit larger just so it's easier to see?
Okay. Is that better? Okay, hopefully that helps. All right, so 0 plus 1, and then we say, let me scroll up. I already kind of lost it. All right, 0 plus 2. All right, so then you end up with negative 1 times 2 equals negative 2. So I know my y-intercept is there. And then the last tip that I had in the notes is that if you know so if you plug into a random point that's between any two consecutive x-intercepts, you could determine the sign of all points in that range. So again, here, just by knowing the y-intercept is at negative 2, I know the graph is going to kind of look something roughly like this. So I see that in my range between negative 1 and 1, the highest I could be is 0 when I'm at exactly negative 1 and 1. And then I know that my other points in between are going to be negative, which means that D, positive 1, is not a possible value. All right, I guess, yes, if I want to end at 8, you know what, so I'm going to actually hold off on number 12 just because it's a little time consuming, because I feel like I could definitely get through 13 to 15 the time I could probably do 12, and we're already almost 8 o'clock. So I'm going to start with 13 to 15, and then we'll kind of see what the time is like, and then possibly I could say a minute or two after do 12, or I'll save that for the hard math webinar. All right, so 12, I'm going to come back to next week or at the very end. All right, so number 13 deals with exponential equations. So first, I just want to kind of give you the formula for exponential equations generally. This is going to be helpful on both questions 13 and 15. So you can think of y is equal to a times b to the x. So a represents the y-intercept, which is the value of y when x is 0. And then b is a constant multiplier. So that's the value by which y gets multiplied by as x increases by 1. So for example, if b were 4, that means you're quadrupling as x goes up by 1. If it were 3, you would be tripling. If it's 2, you'd be doubling. So taking a look at this problem, I see that my y-intercept is 2, meaning that 0, 2 is a point on this graph. So right away, I could get rid of b, which has 1 for my a, and I could also get rid of c, which has 3 for a. A and D, though, they both have the correct value for A. So now it comes down to B. So I know that I'm tripling as Y goes up by 1. So if I just want to kind of write the coordinates of the first few points, so I know I'm starting at 2. And then when X is 1, Y triples to 6. When X is 2, Y triples to 18. And I see that that really nicely matches with A. So A would be correct. Whereas in choice D, we see it actually doubles. So D would be y equals 2 times 2 to the x, because it has the right y-intercept, but it's doubling. All right, so I'm going to do 14, which is a really quick one. So 14 involves function notation. So one thing to remember is that f of a, if you're told that f of a is equal to b, a represents the x coordinate of the point, so whatever in that parentheses of the x, and then the value on the other side of the equal sign is the y coordinate. So sometimes you'll be given X and asked to find Y. Sometimes you'll be given Y and asked to find X. It really depends on the way the question's worded. But a lot of students, when they get these wrong, it's because they do the question in reverse. So if we look at this question, they tell us that we're given the graph of a function above, and they want to know which of the for which value of X. So they're already telling us we want to find X, for which f of X equals 0. So in this case, the key thing to understand about the question is my Y is 0. I want to find an X value where Y is 0. So it has to be one of these 3 points. And I see that 1 is a match. The common wrong answer that people put for this question is they'll put 4. But that would be f of 0 is equal to 4. So that would have been if they said, what is f of 0 before, or they might have said, if f of X equals 4, then what is X? And then it would be 0. So that would be doing the question in reverse. All right, so we'll definitely get to do number 15, which is like a slightly harder variation of 13. And then I'll kind of let you guys decide if you want to do 12 or if you just want to save that for next time, because it would probably go a little bit after 8 to do that one. All right, so on exponential equations, sometimes you need to interpret them in the context of what I call time manipulations. So I'll give you kind of 2 examples of a word problem without and with the time manipulation, and then we'll apply it to the question right before. So suppose you're given this formula, y equals 200 times 3 to the x, where y represents population and x represents the number of years after 1979. So as we remember from number 13, our y-intercept's 200, which is our starting value. So that means my beginning population is 200. And then the b is our growth factor. So I'd interpret this as saying every year the population tripled. So this would just be a basic exponential equation word problem that doesn't have any time issues going on. The next equation, though, is a slightly modified version of this. So again, I still have 200 for my A and 3 for my B. So the first part gets interpreted normally. My starting population is 200 and I'm tripling. However, the x over 4 tells me that I'm tripling every 4 years rather than every year. And you could actually confirm this by plugging in 4 for x. So if I plugged in 4 for x, I would get 3 times 4 over 4 is 200 times 3 to the 1, which is 600. If I did another 4 years later, which is 8, I'd have 8 over 4 is 2, 3 to the 2 is 9, times 200 is 1800. That's another tripling. So that's kind of how they can make it a little bit more advanced. We see the exact same situation pretty much in 15. So they give us this function for the population of water hyacinths and a population over time. They tell us A of t is the number of water hyacinths and t is the time in days since the population was measured. So they want to know the interpretation of 2 to the t over 6. So again, just for review, we know that 12 is our beginning number of the water hyacinths. 2 means that we're doubling, and the t over 6 means that this doubling is happening every 6 days, similar to that population problem I just made up for you. So that would go really nicely with choice B. One thing I do want to point out about C and D, sometimes people put C. So if you're increasing by a constant amount, that's actually linear. So remember, in linear growth, you're adding a constant amount, whereas in exponential, you're multiplying by a constant. All right, so it's 7:58. So if you want, I could do number 12, but it's probably going to go a little bit over 8, like maybe 2 or 3 minutes. So if you want to do that, we can. Or I could save that for the hard math webinar. So I don't know, Francis, what you think? Because I don't want to keep people late.
No, it's fine. It's an extra 5 minutes. Let's go.
Okay, so it's just one question. So I'm not going to do the griddings. I'm just going to do this last multiple choice. So at least we get all that done. So a little background information for this question before we look at it, just as a review. Remember, anytime you have like a circle type shape, the diameter is the total length across and the radius is half the diameter. And then, so that's one general thing to remind you of. Another thing I want to remind you of is anytime you have a question involving volume, there's a very good chance you're going to have the formula in the formula sheet for you. So in this case, we're working with the volume of a sphere. So that formula is given for you. You do not need to memorize it. And that's just something to know. But other problems, you might have a cylinder or a cone. So that's just kind of general background information to kind of get yourself situated. So here they tell us that 2 beach balls are each in the shape of a sphere. The larger beach ball has a diameter of 3x and the smaller beach ball has a diameter of x. So they want to know what the ratio is of the volume of the larger beach ball to the volume of the smaller beach ball. So just ratio you could think of as another word for saying quotient. So another way of wording this question is, what is the volume of the large ball divided by the volume of the small ball? And I know the formula is V equals 4/3 pi r cubed, but they only gave me the information in terms of the diameter. So one thing you can do, which some students do, which isn't wrong, it just makes the math a lot messier, is they simply kind of divide diameter by 2 to get the radius is 1.5x and the radius of the small ball is 0.5x, and they plug those both into the formula. That's not wrong, but you're more likely to make an error with the math, and it makes it a lot messier. So just as a general tip, and this is something you can remember, that anytime you have some sort of circle shape, whether it's a sphere or an actual circle, the ratio between the diameters is also equal to the ratio between the radii. So for example, let's say in that problem, x was 30, and that meant 3x would be 90. So the radii would be 45 and 15. We see 45 is 3 times 15, just like 90 is 3 times 30. So what I recommend doing when you're doing these problems is always let the smaller radius be r, and then find the bigger radius in terms of r. So I'm going to let the radius of my small sphere or the small beach ball be r. And since I know the bigger beach ball has a radius 3 times that, I'm going to let that radius equal 3r. And now I'm simply just going to plug both of those into my volume formula and then do division. So for my larger sphere, which I'll call volume B for volume of big, I would do 4/3 pi parentheses 3r cubed, and then over the volume of the small, which is just going to be 4/3 pi r cubed. So it's actually just my original formula. And then I end up with 4/3 pi, and 3 cubed is 27, 27r cubed over 4/3 pi r cubed. And you might notice the 4/3 pi's cancel out, the r cubes cancel out. So you're left with 27. So the bigger ball has a volume 27 times that smaller one. So D would be correct. And you might notice it ended up just being 3 cubed, which is 27. So had it been twice as large, it would have been 2 cubed, which would have been 8, 4 cubed would have been 64. Just kind of a shortcut you might recognize. And the 4/3 pi ended up not even being relevant because it was the same in both, and they canceled out. All right, so I think that's good for today. So we got through all the multiple choice of the test, of the no calc section anyway.
Everyone, give Douglas a huge, gigantic thank you. Can you please write thank you in the chat box? Let's do thank you. Okay, everyone, let's give Douglas a huge, gigantic thank you for doing this and for putting together the book and for using his ginormous brain cells for the better good. Something I really like to do during all the webinars is to unmute everyone and to use this opportunity to count to 3, and we're going to say thank you. So let's unmute yourself. And if you could please all take a moment and just say thank you. Okay, everyone. 1, 2, 3. Thank you.
Thank you. Thank you.
Thank you, Douglas.
Thank you very
We're
much.
so happy. Okay. Thank you. All right. Okay, we're all set. We learned a lot. We covered a ton of information. And Douglas, thank you. We can't wait to do this again next week and to learn from this. This was really helpful. And I have to say, I genuinely enjoy hearing your voice, your explanations. I know quite a bit over the years, but I have to say, I'm really learning new things here and there. And I'm like, wow, this is great. So I have to give you a gigantic thank you. This is definitely, even for me, such a clear webinar on the SAT. It was super helpful, super spot on. All right. Okay, everyone. Thank you. I'm going to end the recording. Bye.
Sure.